Hi, Pre-Calc students. We are starting part of lesson 5.5. We're talking about double angle formulas, half angle formulas, and the next lesson will be about power reducing formulas. So here are some of the formulas we've already come up with. We have our sine, sum, and difference formulas, along with our cosine, sum, and difference formulas, and then the tangent, sum, and difference formulas as well. All right. Using those formulas, we are going to get new formulas for sine of 2x, tangent of 2x, and cosine of 2x. So this first prompt says substitute a for x and b for x into the sine of a plus b formula. So I'm going to first write the sine of a plus b formula. I'm just going to copy it from above. So sine of a plus b is sine of a cosine b plus cosine a sine b. But then it says let x be substituted in for a and substitute in x for b. So I'm going to rewrite it as sine of x plus x, which will end up being sine of 2x. And then just when I see an a, I'm going to put an x, and when I see a b, I'm going to put an x. All right, now this is our sine of 2x formula, or one of our double angle formulas. And you can see that we have sine x times cosine x plus cosine x times sine x. Since these are multiplied, it doesn't matter which one goes first. So we actually have two of them. That is 2 sine x cosine x. And that is one of our formulas. So go ahead and put a box around it. All right, now we're going to do the tangent double formula, or double angle formula. So I'm going to copy down our tangent of a plus b formula from above. Tangent of a plus b equals tan a plus tan b divided by 1 minus tan a tan b. And again, we're going to substitute x in for a and x in for b. So when I rewrite it, we get tan of x plus x is tangent x plus tangent x divided by 1 minus tangent x times tangent x. And to simplify everything, x plus x is just 2x, so tangent of 2x, our double angle tangent formula. We have tan x plus tan x, which is 2 tan x. You know what, I'll do it in blue. 2 tangent x. And then down below, tangent x times tangent x is just tangent squared x. So there is our second formula. And then we're now going to get our cosine double angle formula. So first I'm going to copy down the cosine of a plus b formula, which cosine a cosine b minus sine a sine b. And they told us to plug in an x for a and x for b, which is ultimately going to get us 2x. And it becomes cosine x minus sine x. And we can simplify this to be cosine of 2x, which is the formula we were looking for, cosine squared x minus sine squared x. And that is different than cosine squared x plus sine squared x, which would have been 1, which equals 1. But this is a different formula, cosine squared x minus sine squared x. Or sorry, cosine squared x minus sine squared x is our double angle cosine formula. Now it says, by using cosine squared x plus sine squared x, we can write cosine 2x in different forms. So it says replace cosine squared with 1 minus sine squared. So it's saying, okay, instead of cosine squared, we're going to plug in a 1 minus sine squared here. So let's see what that does. Again, this is using our Pythagorean identities to rewrite. And negative sine squared minus sine squared is just 1 minus 2 sine squared x. So this is another cosine double angle formula. And then lastly, it tells us replace sine squared x with 1 minus cosine squared. So here we go. Cosine of 2x is going to equal cosine squared x minus, instead of sine squared, we're plugging this in, 1 minus cosine squared x. And we get, I'm going to distribute the negative, so we're going to get negative 1 plus cosine squared x. And now we have 2 cosine squared x, so it's going to be 2 cosine squared x minus 1 is equal to cosine of 2x. All right. Now, on the next page, we are going to just write the formulas that we just came up with. So actually, you can pause here and kind of copy this down if you need to. And then we're going to go to the next page. So we have sine, and I'm going to write it with theta this time. It doesn't really matter. You could write it with x, with theta, with any variable, but the formulas will be the same. So 2 sine theta, cosine theta. Then cosine of 2 theta, the first equation we came up with was cosine squared theta minus sine squared theta. And then tangent 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. All right. So now we're going to do some more rearranging. Rearrange cosine 2x to make sine squared x the subject, or basically just to isolate sine squared x. And then it tells us to replace x with x over 2 and solve. Okay, so let's first isolate sine squared x. So I could subtract 1 from each side, and I'd get cosine of 2x minus 1 equals negative 2 sine squared x. And then we could divide by negative 2. And we're left with sine squared x. Now, after we isolated sine squared x, it's telling us to replace x with x over 2. So every time I see an x, I'm going to write x over 2 instead. And this is to get a half angle formula. So I'm actually going to rewrite it. Let's do sine squared on the left. And then I'm now going to plug in an x over 2 instead of an x. We're just like using a different variable, x over 2. But what happens right here, you'll notice we have a 2 times an x over 2, or 2 over 1 times x over 2. The 2 divided by the 2 is 1. So we end up getting, sorry, I don't want to make it more complicated. Okay, when we multiply 2 times x over 2, that will become just x, because the 2's kind of cancel. So cosine of x minus 1 over negative 2. And then lastly, it tells us to solve for sine of x over 2. Right now we have sine squared of x over 2. So what we're going to end up doing is taking the square root of both sides. But right now, this fraction is negative, right? I could take the negative 2 and make it like kind of a negative fraction. One thing we can do to offset that is multiply the top by negative 1 and the bottom by negative 1, so that we kind of get rid of the fraction or the negative in the denominator. So I'm going to rewrite this as sine squared of x over 2 is equal to, I'm going to distribute the negative 1. Negative 1 times negative 1 is positive 1. And then we're going to have a minus cosine. But then in the denominator, negative 1 times negative 2 is positive 2. So now I don't really have as many negatives as before. And we can take the square root of both sides. And we get sine of x over 2 is equal to plus or minus the square root, because when we take the square root, we always have two answers. 1 minus cosine x divided by 2. And that is your half angle formula for sine. Okay, now we're going to do the same thing for cosine. So we kind of have similar directions. Make cosine squared the subject, then replace x with x over 2, and then solve for cosine of x over 2. So I'm going to take this formula, I'm going to add 1 to both sides to get cosine squared by itself. So we have cosine of 2x plus 1 equals 2 cosine squared. And to get the cosine squared by itself, we can divide everything by 2. I'm going to rewrite it with the cosine squared on the left. Okay, and now it says replace x with x over 2. So I'm going to write that over here. Cosine squared of x over 2 is equal to cosine 2 times x over 2 plus 1 divided by 2. And like what happened in the problem before, 2 divided by 2 is 1. So we're left with cosine squared of x over 2 is equal to cosine of x plus 1 over 2. And then to get cosine of x over 2 by itself, we just square root both sides. And then I'm going to write the final formula over here. We get cosine of x over 2 is equal to plus or minus cosine x plus 1 divided by 2. All right, and let's see, I will derive tangent of x over 2 with you. We're going to use sine squared, cosine squared, and tangent squared using the Pythagorean identity and double angle formula. This is another one of those formulas that I'm just going to give to you. And basically what we're doing is we're just dividing, like, your sine of x over 2 formula divided by your cosine of x over 2 formula, but it gets kind of tricky. So this is the result of that. Tangent of theta over 2 equals sine of theta divided by 1 plus cosine of theta. And another or alternate version of that is 1 minus cosine of theta divided by sine of theta. All right, so down below, we're now going to write all of the formulas we learned today. We had double angle formulas and half angle formulas. And I'm going to give you some extra formulas too. So here are our double angle formulas. Sine of 2 theta is equal to 2 sine theta. Cosine theta. Cosine of 2 theta equals cosine squared minus sine squared, and then the other versions, right, were 2 cosine squared theta minus 1, 1 minus 2 sine squared theta, and then tangent of 2 theta was 2 tangent theta over 1 minus tangent squared theta. All right, here are the extra formulas that we didn't have time to derive, but I'm going to give them to you anyway. Sine squared of theta is 1 minus cosine 2 theta over 2. These are actually taken from the Pythagorean identities. Cosine of squared theta is 1 plus cosine 2 theta over 2, and tangent of 2 theta, 1 minus cosine 2 theta over 1 plus cosine 2 theta. And lastly, our half angle formulas. Sine of theta over 2 is equal to plus or minus 1 minus cosine theta over 2. The cosine formula for half angle is similar, but we have a plus cosine theta over 2. And then the tangent theta is just dividing sine of theta divided by 2 divided by cosine of theta over 2. And we get 1 minus cosine theta over sine, or sine over 1 plus cosine theta. All right, I know that those are a lot of formulas that we're adding to our list that you do need to memorize for the test. But again, you need them for the test. You have to memorize them for our test, but on your final, you will have a note card. So you just have to memorize them this once for our test. The reason is, in calculus, you have to use these formulas sometimes at the end of a long problem. So you need to be familiar with them if you go on to that class next year. All right, thank you guys. Make sure to copy this all down in your note packet, and I will see you next time.